Okay, so permutations, if I'm taking out of n elements and I want an ordered selection of r of them, where r is a number smaller than n, this is we have a permutation, and it's n factorial divided by n minus r factorial. Okay, so let's talk about like what that looks like. So if I have the letters of the word algorithm, and if I count the letters of the word, so I have 9 letters moving around. So how many ways can I move 3 of the letters be arranged in a row? So that's going to be my r is 3. So that's the permutations of 9 and 3. So 9 factorial, 9 minus 3 factorial, and you remember your work with factorials before, right? So this would be 9 times 8 times 7 times 6 factorial, so the factorials would cancel, so you get 9 times 8 times 7. Okay, so I will let you play with these two, because these are pretty straightforward, I think. I don't need to have too many examples of that one. So here that gets a little harder, I think. All right, so I want to know how many 3-digit integers are divisible by 5. Okay, so 3-digit integers divisible by 5. So I'm going to show you a different way of doing it than I just did on the other page, or in the other section. So 3-digit integers, I could have ends in 0, or, which means addition, ends in 5. Okay, so if I have the number 0 here, there's one choice for that, right? And if I have the number 5 here, there's one choice for that. Okay, so it does just 3-digit integers. It doesn't say anything about distinct digits, anything like that. But if I want 3 digits, right, so I picked out the hardest thing first. Always go for the hardest thing first. The next hardest thing is to make sure that it's a 3-digit integer, so I don't want this to be 0, right? So this, I don't want it to be 0, so how many choices do I have? 9. Same for here. I don't want a 0 here, so I have 9 choices here. And I can have any digit here. It's not talking about distinct. I just need it to be divisible by 5, so that had to have a 0 or a 5. So there's 10 choices and 10 choices. So what does that give me? It gives me 90 plus 90, or 180 total, right? Okay. So now we move into the little harder. So now I want you, actually, I'm going to let you do the same thing. I would encourage you to do the same thing, ends in 0 or ends in 5, and I'll let you do this one for Zoom. All right, so then how many, I'll do this one for you because this one's a little more challenging. So one way to do this, and there's going to be different ways, and you can think about these different ways. I want to have digits from here to here, 1,000 to 999, so 4 digits, right? Where can I put the digit 3 once? So 1, 2, 3, 4. I could put the 3 here, right? Or I could put the 3 here. Or I could put the 3 here. Or I could put the 3 here, right? So by me putting the 3 here, there's one choice for that, correct? Okay, so I want to make all the rest of the integers not have a 3, because I've already, in each of these cases, put the 3 down. So this is a 4-digit integer, so for number of choices for here, I have 10 total, but not with the 3, so that makes 9 for the others. Okay. So let's go here. So these others are a little more challenging. Remember, it can't be 0 here, right? So this one can't be 0, and it can't be a 3, so there's 8 choices here. All right, and so then these other 2 digits, they just can't be a 3, so there's 9 choices for each of those. All right. Again, can't have 0 here, and we can't have the 3, so there's 8 choices, and then there's 9 choices for the other 2 digits. Same here, not 0 here, So that's 8 choices and then 9 choices for the other digits. Little tricky, but I think you're up for it.